Hi, Algebra 2 Trig Advanced students. This lesson is on rational inequalities. So let's get started. Let's start with a warm-up. And our job for this problem is to find the equation of the following graph. So you are given information here, and your job is to find the actual equation that you started with. So I'm going to start off just writing f of x is equal to, and I like to draw sort of, line that has, my numerator and my denominator separated. Let's see, I'm going to start off with my vertical asymptotes, okay? And those are going to go on the denominator. So that's going to be x minus 2. We have x plus 3. I'm also going to plug in my zeros, and those are going to be plugged in at on my numerator, which will be x minus 3 and x plus 1. We also have a whole. Our whole is at 5, so that's going to be x minus 5 and x minus 5, because those will disappear. Those are going to be canceling out. That is my equation so far. What I'm missing is my horizontal asymptote and my y-intercept. I just have to double check to make sure that I have everything in, right? So if I think I'm done, I've got x cubed over x cubed, right? Is that going to give me a horizontal asymptote right then? So like if I plug in 2, like here for my horizontal asymptote, is that going to give me, so I've done that, that's going to give me my horizontal asymptote. I just have to double check to make sure that my y-intercept and also my whole, the points, like see the 1/4 here, and also the -1, I got to make sure that those are going to work. So I'm going to erase this right here, and I'm going to plug my numbers in. So the first thing I'm going to do is plug in 0 for my y-intercept. So doing that, I'm going to get 2 times 0 minus 3. So 2 times -3, 0 plus 1 is 1, 0 minus 5 is -5, all over 0 minus 2, this is a minus. So that's going to be -2, 3, and -5, for which those will cancel. My 3's are going to cancel, my negatives are going to cancel, my 2's going to cancel, and when I plugged in 0, I get 1. But in looking right here, I noticed that that's not my answer. And I think a quick fix that a lot of people think is that I can just add in a -2 here, and that's going to make that work. But actually, that's not going to work, because that would make my horizontal asymptote at y equals -2. So at this point right here, this isn't the right equation. I've got most of the answer right, but I don't have the entire equation. So now you have to actually stop and think and go, wait, what is going to make this true? What's going to make my equation, correct? I plugged in all the information that they told me to plug in. But now I need to take a moment and actually look at my graph. I'm looking at my graph. I have this. I'm crossing my horizontal asymptote, totally fine. But right here, it looks like my graph is sort of bouncing off that, doesn't it? It's not going through. And it's touching my x-intercept there at where? At 3, at 3, 0. So it's touching there, which means that my multiplicity for this value is now going to be 2, okay? Similarly, over here, I believe my vertical asymptote is at -3 here, okay? It goes through here at -3. See how my graphs come up like this, okay? Like this. That's also causing a multiplicity of 2. So that vertical asymptote at -3, which is right here, also is going to have an even multiplicity. So I don't know if it's 2 or if it's 4 or if it's 6. I'm going to try 2 and then see if it works. So I'm going to plug my values in again for the whole and the y-intercept. So now I'm going to plug in 0 again. So we have 2 times 0 minus 3, which is -3 squared, which is 9, times 1 times -5, all over 0 minus 2, which is -2, 3 squared again, 9, 0, and -5. Negative 5's cancel, 2's cancel, 9's cancel, and I have 1 divided by -1, which is -1. So when I plugged in 0, I did get -1, so check, that works. Lastly, I would need to plug in, just to be like 100% certain, the values for my whole. And that means that, remember, if you plug in your values at 5, if I plug in 5, I need to plug in 5. But if I did plug in 5 to my original equation without canceling those out, this would give me intermediate form, meaning I'd have 0 over 0, not going to give me 1/4. So what I need to do is cancel those out like I would. You have to simplify, basically. So we're going to go 2 times, plugging in 5. 5 minus 3 quantity squared times 5 plus 1. These are gone. Those are gone. All over 5 minus 2, which is 3, times 5 plus 3. I guess I'll just write that out. 5 plus 3 quantity squared, and then that's gone. So we've got 2 squared is 4. So we have 2 times 4 is 8. 8 times 6, what's 8 times 6? 48 over 8 squared, what's 8 squared? 64 times 3. So you're just going to be canceling. 12 goes into 48 4 times. 12 goes into, I guess, shoot, I just plugged in that. Let me just plug in 8 to start with. 8 goes into 48 6 times. 8 goes into 64 8 times. 3 divides into 6 twice. 2 divides into 8 4 times. So I have 1/4. So when I plugged in 5, I got 1/4. So check, did that. So I just want to be really clear that when you're doing these problems, especially when you're doing these on their test, that's coming up in a week or so, you have to plug in your answers to check. You've got to plug in those points, because that's going to verify, whether you got your answer, the correct equation or not. Additionally, this is another review. We also did this. This was polynomial inequalities. Today we're doing rational inequalities, but we did this last week, which was polynomial inequalities. So I want to practice this too. So we're going to factor first. So, okay, well, actually, the first thing you had to do was to set it equal to 0. Check, it's already done. The second thing is to combine any kind of like terms. Did that. Number 3, factor. So we're going to go, this is an x plus 2, and this is an x minus 1, greater than 0. And splitting these both up, my roots, using sign pattern testing, are going to be a -2 and a positive 1. Okay, and for this problem, we're going to choose a value in between these roots, which I'm just going to choose 0. Plugging in 0, I'm going to get 0 plus 2, which is 2, and 0 minus 1, which is -1. So I get -2 is greater than 0. Is this true? Okay, is not true with a point. Is -2 greater than 0? So, excuse me, is that true? So we plugged in 0, right? And we got this. And you have to ask yourself, is this true or not true? Is -2 greater than 0? No, it's not. Therefore, it's below. It's not greater than, it's below. So we're going to get this. And then because I don't have any even multiplicities, there's no bouncing off. So they're just going to all go through, and this is going to go through. So the question is, back to the beginning, is this: where is the equation greater than 0? That's your question. Where is my equation greater than 0? So it's going to be greater than 0 here and here. So therefore, you're going to put those values in. So we're going to have -∞ to -2, and also we're going to have 1 to infinity. Okay? Another problem, similarly, like this, another polynomial inequality. And the first step you need to do is to set it equal to 0. So let's do that. So we have x cubed minus 2x squared minus 5x, add 6, greater than or equal to 0. This is not going to be done by factoring by grouping. So we are going to try to plug in a number that does work. I'm going to try 1. And just make sure these are decreasing. 3, 2, 1, 0. Okay, done. 1, we have -2, we have -5, and we have 6. So adding down, multiplying across, adding down, multiplying across, adding down, multiplying across, adding down. Okay, so we got that number. So this is going to be this value here. Starting off, x minus 1, that includes this value. And then this is what's left. So if it starts off with a cubic, this is 1 less. So now that's going to be x squared minus 1x minus 6. And this is greater than or equal to 0. Factor again. So we have x minus 1. And then we have x minus 3 and x plus 2 greater than or equal to 0. Now, I do want to make a note in that graphing this, okay, I can graph this, definitely graph this, but the problem is that when we're doing polynomial inequalities, you can graph or you can use sign pattern testing. You could do either one. So a lot of people will be like, I don't have to use sign pattern testing. I know what the graph looks like. I'm just going to graph it. The problem is that today when we learn our rational inequalities and not polynomial inequalities, rational meaning you got fractions, you have to use sign pattern testing. You have to use sign pattern testing. You're not going to be graphing. So while today in reviewing what we're reviewing, polynomial inequalities, we can use graphing or we can use sign pattern testing. So for example, if I were graphing this, right, I know my y-intercept is positive 6, that's up here. I know my roots are going to be 1, positive 3, here's 3, here's 1, and -2, okay? And then I know it's a cubic, see, cubic right there. I know it's a positive cubic, so I know my end behavior is up, right, down, left. So it goes up, and then I know this is happening down. And then I know that my graph is going to do something like that, and because there's no multiplicities, everything's going right through. That being said, the question is, again, where is my graph greater than or equal to 0? So it would be here, right? And then over here. That goes through that. Well, on sign pattern testing, okay, you do the same thing. We're going to plug in our values. We've got a -2, we have a positive 3, and we have a positive 1. And somewhere in between, we're going to select 0 or some number that's in between. I'm going to choose 0. Plugging in 0, I'm going to get 0 minus 1. I get -1 times -3 times 2. 6. Is 6 greater than or equal to 0? Yes. So therefore, at 0, it's true, it's greater than or equal to 0. I have no even multiplicity, so everything's going to go through. It's going to go like this, okay? So that means that the question is now, go back to the beginning. And I know this isn't actually written out. It's just like, solve it, okay? So you have to know what the question is embedded in the equation, okay? And the question is this: where is the graph greater than or equal to 0? That's what I want to know. So you know it's going to be greater than or equal to 0 here and here, okay? So therefore, my answer would be, just like in my picture up here, right? Just like by graphing, that's what it would be. So it's going to be from bracket -2 to 1, and also 3 to infinity. So 3 to infinity, okay? So today, we're learning about rational inequalities. Now, rational functions are like fractions, like this. See how it's a fraction? Oh, I love my Starbucks. Anyway, so there's some rules to solving rational inequalities. Number one, the first thing you need to do, write this down if you don't know this already, is to set the equation equal to 0. Okay, you need to simplify, all right, first. So number one, set it equal to 0. Number 2, simplify. Number 3, I know it says step 2, but technically number 3 is you need to find the numerator values and the denominator values that are your critical values. That means where are each one of my denominator values after I factored, where are my values equal to 0? Okay, so I guess, so number 3, technically, would be to factor. I may have to redo this. Factor. And number 4 would be to identify all your zeros. I want to know that. And then lastly, you're going to use sign pattern testing. Equal to 0, number 1. Factor next. So we're going to go x plus 2. We're going to say x plus 1. And then on the denominator, we have x minus 4, and we have x plus 4, and greater than or equal to 0. So I'm going to do my sign pattern testing. I'm going to plug all the zeros in the numerator and the denominator. Those are my critical values. I've got a negative 4 from here, okay? I've got a positive 4 from this side here. I've got a negative 1 and a negative 2, all right? Okay. Additionally, I'm going to plug in the number 0, which goes around here. So plugging in 0, that's going to give me 2 times 1 over negative 4 times 4. So that's what? 2 over negative 16, which makes negative 1, 8. So is negative 1, 8? Is this a true statement? Yes or no? Is it greater than? It is not greater than. So if it is not greater than, it is less than. So now we're going to go down like this and go like this. And because there's no even multiplicity, this is just going odd, even, odd, going through, like that. So now the question is, going back to the beginning, where is my graph greater than or equal to 0? So it's greater than or equal to 0 here, here, and here. I've got 3 different places. So I'm going to put in all the values. So I've got negative infinity to negative 4 union, and I've got 2, negative 2, greater all the way to negative 1. And I also have 4 to infinity. Now, just a note, I really want to make sure you understand this. Do you see how the denominators, those are my asymptotes. Those are my VAs, my vertical asymptotes. My vertical asymptotes, which are here and there, cannot equal 0. So I want to know where, even though it says greater than or equal to 0, your vertical asymptotes can never equal 0 because there's no value there. So that's why they're just going to be parentheses on, so you can, on my vertical asymptote. So just a note, you can go through and put brackets all throughout, but remember that you're going to need to fix the ones that are vertical asymptotes. Like this one would be a parenthesis. Even though it looks like it'd be a bracket because it's greater than or equal to, it's never going to be a vertical asymptote because you can't touch it. A little trickier, we're going to have to subtract. So we're going to have 2 over, I'm going to factor at the same time. We have x minus 3 and we have x minus 1 minus 5 over that value, which is going to be x plus 3 and x minus 3, greater than or equal to 0. So first we set it equal to 0. Now we need to combine like terms, and combining like terms includes having the denominators the same value. And so this has an x minus 3, that does 2. That has an x plus 3, that doesn't. So this needs an x plus 3 over an x plus 3. This has an x minus 1, this does not. So this would be an x minus 1, because you're allowed to manipulate the problem such that you can multiply by 1 in any form in order to combine those terms. Because right now, what I just did was now I have a common denominator. I have x minus 3, I have x minus 1, and I have x plus 3, all the same, greater than or equal to 0. And then here, I just need to simplify. So distributing, we get 2x plus 6. Distribute, I get minus 5x, add 5. Keep simplifying. I get 2 minus 5 is going to be a negative 3x plus 11 all over this, x minus 3, x minus 1, x plus 3, and we have this greater than or equal to 0. And so right here, what I'm going to do is I'm going to factor out this negative sign, And in doing that, I mean, basically just ask myself, negative 3x plus 11 equals 0. Negative 3x is negative 11. X equals 11 thirds. So that's one of my zeros. So making the line, okay, for my zeros, I've got an 11 third. 11 third is what? 3 and 9, 10, 11, 2 thirds. Okay, so we have a 3 and 2 thirds. All right. We have this value, which is a negative 3. We have this value, which is a positive 3. And we have this value, which is a 1. So I'm going to pick a number in between that, and I'm going to choose 0 again. I like choosing 0, unless I can't. And then we're going to plug that in. So if I plug in 0, I get that 0. I get 11 over, let's see here, negative 3 times negative 1 times 3. So that's going to be 9. 11 ninths. Is 11 ninths greater than or equal to 0? Yes. So here, this is a true statement, and we don't have any multiplicity, so everything goes through. So this goes through, this goes through, this goes through, this goes through. Okay? So go back to the original equation and say, okay, what was my original equation? Once you set it equal to 0, that's your original equation. So it's going to be, where is my graph, okay, greater than or equal to 0? So it's going to be here, and it's going to be here, okay? So now I'm going to plug my values in, so I know it's going to be up here. So it's going to be, and I know it's greater than or equal to, but you have to remember your asymptotes cannot equal 0. So here's my negative 3. This cannot equal 0. That's a parenthesis. My 1 is a parenthesis. My 3 from here is a parenthesis, but this is a bracket. So you're going to have, so you're going to say negative 3 to 1 and 3 to 3 and 2 thirds. What is that, 11 thirds? Okay, and that's a bracket. Okay, cool. That's my answer. Are you getting it? Okay, let's do another one. Factor first. It's already set equal to 0. So we're going to go x minus 5. We're going to say x plus 2. This is going to be an x minus 2 greater than or equal to 0. I'm going to say my zeros are, what are they? 5, okay, negative 2, and positive 2. I'm going to choose 0 in between. So that's going to give me negative 5 times 2 over negative 2. 2's cancel, negatives cancel. I get 5. Is 5 greater than or equal to 0? Yes. So that means this is true. So here it's up, through, and this is down. So the question is saying, where is my graph greater than or equal to 0? Here and here. So my answer is going to be, remember, this value, and if it's easier to put in your asymptote parentheses here, parenthesis, negative 2 to this value 2, which is a bracket. 5 is another bracket because it's on the top. So that's going to be bracket 5 to infinity. That's my answer. Okay. Another problem. We have x plus 4, factor x plus 4. We have x minus 4. We have x minus 5. And we have x plus 1 greater than or equal to 0. And so we're going to have line, we're going to have 5. We're going to have negative 1. We have negative 4. We have positive 4, negative 1. Okay, and plug in the value 0. And so we're going to go 4 times negative 4 over negative 5 times 1. So that's negative 16 over negative 5, which is 16/5. Is that greater than or equal to 0? That's a true statement. So here is up. We have no multiplicities, and it does this. Down, up. Okay. So that means the question is, where is it greater than 0? Here. here, and here. So that means it's going, and put in your asymptote value. So I know that at 5, here, that's a parenthesis. I know at -1, also a parenthesis, because those are my vertical asymptotes. So this is going to be parenthesis -infinity to 4, -4, bracket, union, -1 to 4, bracket, what else? Union 5 to infinity. And so that whole thing is my answer. Solving the inequality, we have x minus 1, oops, and x, well, that's not going to work. You know why? Because it's not set equal to 0. So the first thing I need to do is set it equal to 0. See, this needs to go over there. So we have x squared minus x plus 1 over x plus 2. Minus 3 is less than 0. We need a common denominator, so I'm going to multiply by x plus 2 over x plus 2. And so I'm going to get x squared minus x plus 1. Now see this negative? I'm going to distribute minus 3x minus 6 over x plus 2 less than 0. And so we're going to get x squared minus 4x minus 5 all over x plus 2 less than 0. I need a factor. This is going to be x minus 5 times x plus 1 over x plus 2 less than 0. Use my zeros. Let's use our sign pattern testing. So our values are going to be 5, -1, and -2. So -2, and here's -1. I'm going to choose a number in between here, 0, I love 0. And that's going to be -5 times 1 all over 2, which makes -5 halves. Is -5 halves less than 0? Yes, so it's true. So it's up here, up, down, like that. So what now? So where is my graph less than 0? Here and here, okay? So your graph is going to be from, where's the graph less than 0? So it's going to be parenthesis, -2 to -1. Oh, and it's just all parenthesis because there's no brackets involved. So this will be to -1 and also 5 to infinity, okay? Last one, we need to set it equal to 0. So we have x over 2x minus 1 minus 3 over x plus 2 less than or equal to 0. I need a common denominator. Common denominator is going to be both of these denominators. So this needs a 2x minus 1 over a 2x minus 1. This needs an x plus 2 and an x plus 2. So we have x squared plus 2x minus 6x plus 3 all over both 2x minus 1 and x plus 2 less than or equal to 0. Common denominator is going to be, well, denominator, x squared minus 3x plus 3. Nope, that's minus 4x. Let me fix that. Okay, minus 4x, because 2 minus 6 is 4. All over this, which is 2x minus 1 and x plus 2. And then we have x minus 3, we have x minus 1, we have 2x minus 1, and we have x plus 2. So the question is, plug in 0. So let's put in our zeros. We've got, let's see, 3. There's 3. We have 1. We have -2. And this one, which is 2x minus 1 equals 0, 2x equals 1, x equals 1/2, which is here. I'm still going to plug in 0. Okay, so I get -3, -1. I get 0 minus 1 is -1, and I get 2. These cancel. Is -3 halves less than or equal to 0? Yes. So that's a true statement. It's going to go up, down, up, down. Okay. So the question is, where is my graph? What is the question? Where is my graph less than or equal to 0? So it's going to be down here, down here, down here. So my answers are going to be negative infinity to negative 2. Negative 2 is one of my asymptotes, and this is equal or less than, so it is a parenthesis union. We're going to go with 1/2, which is another denominator, so that's going to be 1/2 to 1, and 1 is not a denominator, so that's a bracket. Union 3 bracket to infinity parenthesis. So that's all I've got for you today. I hope that helped you, and thanks for watching.